Welcome to day 7. Today we are going to see bitwise operators. In previous sessions, day 5 and day 6, we discussed about arithmetic operators. Arithmetic operators plus minus star is for multiplication, slash is for division, double slash is for floor division, double star is for power, and modulus operator is for remainder. Second one, we discussed about relational operators, relational or comparison operators, greater than, less than or equals to, greater than or equal to, not equal. Third operator, compound assignment operators, plus equal to, minus equal to, star equal to, slash equal to, double slash equal to, and all. Fourth operator, we discussed about logical and logical or and logical not. So today we are going to see fifth bitwise operators. So before we start our bitwise operators, we will see binary numbers. So binary numbers are those numbers which are having only zeros and ones. Computer understands only binary number. So first of all, we will see how to convert a number into binary. So first of all, you have to write 1, 2, 4, 8, 16, 32, 64, 128. So to convert any number into binary number. Suppose I want binary number of 10. So you have to select those numbers which can added and that addition will be 10. So here 8 and 2 are those two numbers which can give you 10. So I am giving 1 and 1. Rest of the numbers are 0. So in right hand side, yes, you can give. So this is binary number of 10. So I want to calculate the binary number of 13. So binary number of 13. So in Python, you can direct write bin 13. You will get binary number 1101. So how to get binary of 13? So which numbers are there which can generate 13 after addition of those numbers? 8 plus 4, 12 plus 1, 13. So 1, 1, 1. Rest of the numbers are 0. So this is what binary number of 13. Okay. So here, these are what bit positions. 1, 2, 4. So one's bit position is 0. Two's bit position is 1 till 128. This is 8 bit. Okay. So binary number of 13, 1, 0, 1, 1, 0, 1, 1, 1, 0, 1. Binary of 13 is 1101. So bitwise and operator. So how many operators are there in bitwise? I will write bitwise and we are going to see bitwise and symbol is this. Second one is bitwise or the pipe symbol, which is located on above the enter button. Okay, bitwise or XOR, bitwise XOR cap symbol, bitwise not, then left shift operator, and right shift operator. So we are going to see these all operators in this session. So what is the logic? How bitwise and works? So here bitwise and operator works on two conditions. If first statement, first bit and second one both are 1, then it will generate 1, otherwise 0. Here both are not 1, here both are not 1, both are not 1, therefore they are 0. So I am calculating what is the bitwise and between 12 and 10. So first of all, you have to calculate the binary of 12, binary of 10. So here to calculate the binary number, first you have to write 8 bits. 1, 2, 4, 8, 16, 32, 64, 128. Okay, so create a box. So here we have to see where we can get 12. 12 we can get here. 8 plus 4. Here you can fill 1, 1. Rest of the boxes fill with 0. This is 12's binary number. 1, 1, 0, 0, 12. Then we will see the binary of 10. So construct another box. 1, 2, 3, 4, 5, 6, 7, 8. Here 10 means what? 8 plus 2, 10. So write 1, 1. The rest of the numbers are 0. So 10, 1, 0, 1, 0. Now I already told you that bitwise and if these two are 1, then the answer is 1. Otherwise 0. Both are not 1, 0. Both are not 1, 0. Both are not 1, 0. Both are 1. So here we will get. So this is the binary number of which number? 1, 0, 0, 0 means don't count 0, count only the position 8. So here 8 is the answer. So if you run this, you will get 8. 8 is the answer. Then bitwise OR. OR means if you have both 0, then answer is 0. Otherwise 1. Both are not 0, 1. Both are not 0, 1. Both are not 0, 1. So here again, I will calculate the binary of 12. Okay. How to calculate directly without writing? How to calculate bin of 12, double one, double zero, bin of 10, 1, 0, 1, 0. Correct. So here 1, 1, 0, 0. This is 12. 12's binary number. 10's binary number is 1, 0, 1, 0. 1, 0, 1, 0. So what is the logic of bitwise OR? If both are 0, then only 0. These are 0, so 0. Both are not 0, so 1. Both are not 0, 1. Both are not 0, 1. So this is the binary number of, 1, 2, 4, 8. 8 plus 4, 12 plus 2, 14. So you will get 14. If I run this, I will get 14. Bitwise XOR. So here result bit is 1 only when two bits are different. Same means 0, different means 1. See here, A and B both are same. So A XOR B is 0. Both are same, 0. Both are same, 0. Both are not same, 1. Both are not same, 1. We'll see 12 and 10. Okay. So here the binary value of 12 is 1, 1, 0, 0. Binary value of 10 is 1, 0, 1, 0. If both are same, then 0. Both are same, 0. Both are not same, 1. Both are not same, 1. Both are same, 0. Means you are getting how much? 6. 4 plus 2, 6. Here I will run. I will get 6. Not. So there is a formula for not. Any number. If you take any number, not of 4. First you have to add 1 in this 4, then after adding 1 you have to apply minus, means final minus 5. Bitwise not of 6 equal to 6 plus 1 minus 7. So I will run print not of 4. I will get minus 5. Not of minus 5. I will get minus 6. Okay, this is the formula. Not of 0 minus 1. Not of minus 1. Not of minus 1 means how see, not of minus 1 means first of all you have to add 1, then apply minus. So minus 1 plus 1, 0. So minus 0 means 0 only. So that's why you are getting 0. Left shift. So left shift means it will shift the bits to left side. When we use left shift, whenever you want to multiply any number which is in the form of 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3. So any number, let's say 5. If you want to multiply 5 into 2 raised to power 0, 2 raised to power 0 is 1. So you'll get 5 only. 5 into 2 raised to power 1. 2 raised to power 1 means 2. 5 to the 10. Okay. So here see, num is 5. Left shift operator 1. Left shift operator 1 means this 2 raised to power 0. Sorry, this one. Okay. So num is 5. Whenever you want to multiply 2 raised to power 0. So 2 raised to power 0 means 1. 5 ones are 5. This is 1. Okay. So whenever you want to multiply 2 raised to power 1, 5 into 2, 10. So here num is 5 and you are shifting 1 means 2 raised to power 1. So multiplying 5, 2 raised to power 1. So I will run this. Again, I will run print num left shift operator 0. Then here we will see 5 means this one. 2 raised to power 1 means we will get 10. Num means 5. Left shift operator 2. 2 means 2 raised to power 2 means 4. We will get 5 for the 20. Num means 5. Left shift operator 3 means 2 raised to power 3. 2 raised to power 3 means 8. 5 into 8, 40. Right shift operator means we have to divide by 2 raised to power n. So here 80. Num is how much? 80. Here print num right shift operator 0. 0 means how much? 2 raised to power 0. here. It is nothing but it is similarly equal to num into 1. So you'll get both the answers correct. 80, 80. Got it? So here, right shift operator, num means 80, right shift operator 1. Right shift operator 1 means into 2 raised to power 1. Sorry, divide by 2 raised to power, sorry, here my mistake. It is right shift operator. So right shift operator, suppose we have num equals to 80. So I'm writing num right shift 0. Right shift 0 means 2 raised to power 0 divided by 2 raised to power 0. Divided by 2 raised to power 0 means 1. So we will get 80. Num is 80. Right shift operator 1. Right shift operator 1 means divide by 2 raised to power 1. 2 raised to power 1 means 2 only. So 80 divided by 2 is 40. We will get 40. 80 right shift operator 2. Right shift operator 2 means divide by 2 raised to power 2. 2 raised to power 2 means 4. So num divided by 4. You will get 20. Num right shift operator 3. Right shift operator 3 means divide by 2 raised to power 3. 2 raised to power 3 means 8. So num divided by 8. Then. So here we have operator and, bitwise or, bitwise XOR, not, left shift and right shift. Okay, so here we have some example, so you can try it at your own. Okay, here you can convert binary of 9, binary of 5. So bitwise and, then you will get answer as 1. Or is 13, XOR 12, x 9 plus 1 10 minus 10, x is 9. Left shift operator means into 2 raised to power 1 means 2, means definitely we will get 18. X right shift operator 1. Right shift operator 1 means 2 raised to power 1 divided by 2 raised to power 1. 9 divide by 2 raised to power 1, 4.5. It will give you floor division. 4.5 floor division is 4. Okay, so bitwise operator and, or, not, XOR, not, left shift and right shift work on the binary form of numbers. So I'm stopping here. Thank you guys. Thank you very much.